Welcome back to the Learning Studio. You're watching our mathematics series in the section on data, algorithms, and computation, where we uncover the mathematical engines powering AI, data science, and modern computing. If this is your first time here, make sure to follow us by clicking the link below. And remember, the full playlist is in the description, so you can explore this journey from the very beginning. Today's topic is matrix factorization and tensor decomposition, the techniques that fuel recommender systems, natural language processing, and much of today's data-driven world. Think about it. When Netflix suggests your next favorite show, or Amazon recommends a product you didn't know you needed, what's happening behind the curtain? Or when a chatbot like Siri or ChatGPT processes language, how does it break down the overwhelming complexity of human words? The answer lies in breaking big problems into smaller, structured parts. And that's exactly what matrix factorization and tensor decomposition do. Core concepts explained simply. Here are the essentials. Matrix factorization. A large matrix, like a user item ratings table, can be decomposed into smaller matrices that capture hidden patterns. For example, instead of storing every possible user preference, we discover underlying factors like interest in comedy or preference for action movies. This is the foundation of many recommender systems. Tensor decomposition. A tensor is like a multidimensional generalization of a matrix. Think of it as a cube or hypercube of data. Decomposing tensors reveals complex structures, like time-based patterns, multiple relations in text, or image layers. In NLP, tensor methods help capture relationships between words, contexts, and meanings. Why it works. These decompositions compress huge datasets into manageable parts while preserving the most important information. They allow us to see hidden dimensions of data. Why it matters in AI, computing, and technology. Matrix factorization and tensor decomposition are everywhere in modern AI. In recommender systems, they predict what you'll like next, powering Netflix, Spotify, and Amazon. In natural language processing, they extract semantic meaning from text and help models capture context. In computer vision, tensor methods are used to process multidimensional image and video data. In dimensionality reduction, they simplify complex datasets into key components, making training AI models more efficient. These tools transform raw data into structured knowledge, turning overwhelming complexity into actionable insight. So, matrix factorization and tensor decomposition are more than mathematical tricks. They're the engines driving personalization, recommendation, and language understanding in our everyday digital lives. In our next episode, we'll take this even further into spectral theory, exploring graph Laplacians, dimensionality reduction, and how eigenvalues reveal hidden structures in networks and data. Don't forget to follow us by clicking the link below, and check out the full playlist in the description. With each episode, we're uncovering the mathematical heartbeat of AI, data, and computation.